A probability function is a mathematical function that provides a model for the probability of each value of a discrete random variable occurring. A probability function has two important properties. 1. For each value of the random variable, values of a probability function are never negative, nor greater than 1. 2. The sum of the values of a probability function taken over all of the values of the random variable is 1. Now we have an example. Throw a dice 2 times and the possible outcomes are this. Now what is the probability function of the dice throw being 4? We see the table and the first line represents the probability of not getting any 4. These are marked with the color green. Now the second line represents the probability of getting 1 4 and it's marked with the color red. The third line represents the probability of getting 2 4s and it's marked with the color yellow. Now we can see that none of the probabilities are bigger than 1 and that the sum of them is equal to 1.
The density function, often represented as capital Y, is a very important function because when we integrate it with the parameters of the workspace, we will be able to find several probabilities that are in these functions depending on the parameters that we have established as our workspace. As we can see in this graph, we have f of x and the area under the curve, which is S, and here are the parameters A and B. This will be the whole probability that we will find in this example. Density function has two important rules that have to be accomplished in order to know if it is a true density function. First, the first rule we have to accomplish, or that has to be accomplished, is that y has to have values greater or equal than 0, and the second one is that the integration of the workspace has to be 1 always. Let's do an example to make it clearer and try to solve it. The example says that height of trees in a zone goes from 2 meters to 6 meters and have a density function like the following, which says that y has the value of x over 16, while x has values between 2 and 6. In other values, y, the density function y has 0. Find the probability of picking a tree randomly, and the height of this tree will be between 3 and 5. First, we have to check that the density function accomplishes the first two rules. And here we have the rule, and we will have to check the first part of this density function, which says that x over 16 will be the density function, while x has values between 2 and 6. We will have to graph this function, and we will find that the parameters 2 and 6 have values greater and equal to 0. So the first rule that says that y has to take values from 0 over is accomplished. Then we have to check that the integration from the workspace is equal to 1. We have to apply the techniques that we have learned from integration, and we take away the constant from the integral, and then we solve it, which is a very simple integration, and the result of this is x squared over 2, but we have to multiply the constant that we took away, and the result is x squared over 32. Then we have to evaluate the function, and we know that is 32 over 32, which is equal to 1. With this, it is proof that the second rule is accomplished. Now we will have to solve the problem that says that what was the probability of picking a tree, and the measure of this tree will be between 3 and 5. We have to integrate this function we have in here with these new parameters, which is 3 and 5. We already know the answer of the integration. All we have to do is evaluate it in the numbers 3 and 5. We did the evaluation, and the result of this is 0.5, which is the answer of the question made. what is the probability of picking a tree, and this tree has the measure between 3 and 5, and the result is 0.5.
Now we're going to talk about a new concept, a distribution function or cumulative function. A distribution function or cumulative function is a function that represents the cumulative probability of random variables. There are three properties for a distribution function. As you can see, the limit of the function to minus infinite is 0, and the limit to infinite is 1. This means that the function has restriction values between 0 and 1, which indicates the probability. The other property is that it is an increasing function. It is never going to decrease, and it makes sense since it cumulates the probability. Random variables are often classified according to their probability distribution function. In any analysis of quantitative data, it is a major step to know the form of the underlying probability distribution. We can find discrete distribution function or continuous distribution functions. We are going to see an example of any of these. We have here the binomial distribution function, which is the simplest function for discrete variables. We can see here the function of the distribution and its parameters like the mean and the variance. In order to understand this function, we are going to compare it with a probability function. So now we have here the probability function. It increases and decreases. And now we have here the distribution function. We can see how it has 0 and 1 as its limits, and that it is always increasing. Now we're going to compare both probability and distribution function with a continuous variable. We are going to use as example the normal distribution function. Now we can see a perfect normal distribution probability function, and we see how it increases and decreases in some points. Then we have here the distribution function, and we can see the same properties, the 0 to 1 interval and the always increasing weight. With this we can now solve the important characteristic of distribution function, also known as ogive.
First things that we have to know is that capital Y is the variable and Y are the values that Y can take. Now we have a probability function, and we have the next values to P, that when Y is equal to 1, P, when Y is equal to 2, for P, when Y is equal to 3, and 0 to other values. The first step that we have to do is put the values in a table. And now we have to calculate the accumulative function. 2 times P, 3 times P, and 7 times P. And the symmetry of all it has to be equal to 1. So 7 times P is equal to 1, and P is equal to 1 over 7. And now we have to put the new values in the table. Now we have to calculate the probability of an interval. The interval is between 3 and 0, but we are not including the 3 and we are including the 0. And the probability is equal to 3 over 7. Now we can see the expected value or the mean. The expected value is equal to the symmetry of the probability times the value. And also we have to see the formulas of the variance and the standard deviation.